Good day, students. Today we are going to give the polar form, the highest form of rotation, and the critical component of this section is that it makes students to become a perpendicular object in the exam room on the premise of the fact that it's a game of a cat and a mouse. Well, before you watch this game, please make sure you subscribe to the channel for more mathematics content in a Mzansi context. Today we are looking at polar form of a complex number, not real number. Please get that. We are going to be working with the imaginary numbers, that is your I, not real numbers from your high school. So I'm saying that the complex number z, which is given by the real number plus the imaginary number multiplied by the imaginary unit I in standard form, which is known as the rectangular form, is written in polar form as z, which is going to be equals to the absolute value of z, or the modulus of z, into cos of the principal argument, which is the angle, plus I sine of the principal argument, then the same angle right there. Now I'm saying that write the following complex numbers in polar form. So the other words for polar form is when they say in modulus argument form. So they wanted to represent your R and your angle. But to get the wider view as to how you're going to get the angle, because the R, it's easy against the argument. Let's do it condescendingly to say, well, number one, I'm going to write solution. Number one, I'm given a z, which is equals to minus 3 root 2 plus 3 square root of 2 multiplied by I. So this one can be represented in the eigenplane where you have the points. So this is your A and this is your B. All right. So I'm going to say, well, let me have the point that is negative 3 root 2 and 3 root 2. So I'm going to try to graph this one in a complex plane or in the eigenplane and really see how my angle is going to behave, and also my my R, the absolute value. So let me try to draw it. So if you look at it, I have a negative value for x and then positive value for y. That means I'm going to draw this in the second quadrant. So I'm going to have my triangle like this in a, let me check. I think it's fine now. Let me just draw it nicely. Perfect. Now it's good. So this is the adjusted side. You know, it's a point P there. This is a point P. So you're going to have a negative length of the adjacent, and that is negative 3 root 2, and then the y, the opposite length, that is a positive 3 root 2. So we need to get this particular length just right here. You can use Pythagoras theorem to really do that, and we are going to say to ourselves, therefore our R is equals to the absolute value. That means it's positive. The length of the hypotenuse is always positive, so we're going to represent that by the absolute value, or the modulus of z, which is going to be equals to the square root of the adjacent squared plus your opposite squared. All right, and that is going to be you're going to get a negative 3 square root of 2. You square that plus 3 square root of 3. I mean square root of 2 there. And then you have to square that, and as a result, you're going to really get something there. Let's check what are you going to get. You're going to get, this is going to be 9 times 2, times 9 times 2. It's primarily like 18, so this is going to be 18 plus 18. Yeah, I need to be very careful there. Yeah, and then 18 plus 18, it's primarily 36, so you're going to get a root of 36, and as a result you're going to get a positive 6. So this is your R. You are basically saying that you have a 6 there for the length of the hypotenuse, or it's called the modulus of the complex number, that is your z. All right, so now you want to get the angle. How do you get the angle of this situation? You are going to measure this from the positive x-axis, and that is to say, if I measure that, I'm going to get it in that way. So we are talking about that angle. That is your theta that you want to find. All right, but you will see that there are many ways to find that theta. I'm going to show you 3 of them, how to find that angle theta. Now, check. If you want to use trig ratio, you're going to say, first thing first, let me have a sine of theta. A sine of theta, it's primarily going to be your opposite over hypotenuse. All right. So that is going to be equals to 3 root 2 divided by 6. And you can simplify this to say, therefore, a sine of theta is equals to root 2 divided by 2. If you simplify this one. I wanted to check something. This number here, it's a positive number, just right here. So you're going to go back to high school and check that where is sign positive. This positive basically tells you where is sign positive. So sign is positive in the first quadrant and the second quadrant. And be careful, in the first quadrant, it's primarily your reference angle. So I'm going to get my reference angle now to say, well, let me get a reference angle. So this is going to be arc sine of the positive of root 2 over 2, and that is going to give you a pi over 4. All right, that is 45 degrees if you are working in degrees, but we work with radians, remember that. So you are going to then now say this one is the angle in the first quadrant. You also need the one in the second quadrant where sine is positive. So you're going to look at the quadrant here. So here, that is your reference angle, and then here it's primarily a pi 1. It's 180 minus the reference angle, just right there. So I'm going to then say that therefore my theta is going to be pi, which is 180 minus, in the second quadrant, it's primarily 180 minus. So this is going to be pi over 4. And if you do that, you're going to get what? Let's check. You're going to get, this is going to be over 4, and this is going to be 3 minus, it's going to be 3 minus pi. No, it's going to be 4 pi minus 3, minus pi. So it's primarily 3 pi. Or you can type it in your Casio. It's really going to give you 3 pi over 4. If you do it in that way. For those that are a bit confused, we are going to be using this particular situation to say here everything is positive, so we're talking about all your reference angles here, and then here we're talking about 180, which is primarily pi minus your reference angle, and then here it's pi plus your reference angle, and then here it's primarily 2 pi minus your reference angle. That means 360 minus theta, or your reference angle, or it can be alpha. And then here, that is 180 plus. So we are now here in the second quadrant, hence I had to subtract that situation. So it means my theta now, it's primarily this one. So I need to write this in polar form. How do I do that? I say, well, in polar form, I have z is equals to my r into cos of theta, and then plus I sine of theta, which is this particular formula here. I just gave it to you. It's this one for free years. That is your polar form, or the modulus argument form. So this would be very easy to say now that your r, you found it to be 6, just right here. That was your r. So you're going to say, therefore, z in polar form or in modulus argument form is going to be 6 into cos of the angle. So your angle is primarily what? It's primarily 3 pi over 4. And then plus I sine of the same angle, that is 3 pi over 4. This is how you're going to get that. But remember, I said I want to show you 3 ways of getting the angle, because I think in most cases than not, students are confused about how to go and find the angle theta. So let me just give you the other method. That is to say, if because I was working with a sine, I want to work now with a cos theta. That is going to be equals to the adjacent over the hypotenuse. I'm going to look at my diagram. The adjacent is minus 3 root 2 over hypotenuse, which is going to be 6, just right here. So let's go and do that. So this is going to be negative 3 square root of 2 divided by 6. And you can still simplify also here to say that is primarily, let me say, cos of theta is going to be equals to negative of root 2 over 2. Now, you're going to check where is cos negative. This negative tells you where is cos negative. So you're going to draw this situation here and say cos is negative in 2 quadrants, that is in the third and the second quadrant. This is where cos is negative. Now, check. It means you need to get your reference angle. That means you're going to say a reference angle is going to be arc cos of this number. This negative tells you where is cos negative. That means now you're going to type root 2 over 2, the positive 1. And if you do that, you're going to get pi over 4. Now you want to get the actual theta to say, well, my theta is going to be equals to, you look at this quadrant. Where is your diagram drawn? Your diagram is drawn where? In the second quadrant. Remember, you're still working with this one. It's drawn in the second quadrant. So you're going to really look at that to say that is pi minus your reference angle. So your theta now is going to be pi minus pi over 4. And that will still give you 3 pi over 4. This is another way of working it out. The third one, which is the last one, I guess, it's if you want to work with the cos. I mean, with the tangent, because so far you worked with your sine, you also work with your cos trig ratio. Now I want to work with my tangent. So I'm going to say the tangent of theta is going to be equals to the opposite over the adjacent. All right. So the opposite, you look at your diagram, that was this situation over this situation. So it's primarily 3 root 2 over negative 3 root 2, which implies that you're going to get a tangent of theta equaling to negative 1. Same stuff here. I'm going to say to myself, this negative, it tells me where is tan negative. So tan is going to be negative in 2 quadrants. That is the second quadrant and the fourth quadrant, because here cos is positive. I mean, tan is positive. I'm now going to look at the tangent. It's negative in the second or the fourth. But I, however, need to get the reference angle. So my reference angle is going to be equals to the arc tangent of this number called 1. The negative, you don't type it. You type it when you want to find some integers there. So you're going to write positive 1 there. It's a reference angle that gives you pi over 45 again. So because your diagram is drawn in the second quadrant, and that's where you get a pi minus a reference angle, it means it's going to be pi minus your pi over 4. This is how you're going to write your theta, and that is going to give you 3 pi over 4. Please check that I'm getting the same angle throughout, which is 3 pi over 4. Even here, I call the same stuff. So please make sure that you choose the one that you find it easy for you. Between the sine and the cos and the tangent, they all work the same way. They just need a maximum level of understanding of trigonometry stuff. So I'm now going to look at the second one, but the answer should really end here. This is how you represent your stuff. The answer should really end here. Here is the answer for the first one in modulus argument form. It's really easy. I don't want to lie. This is really easy. Now, the second one, let's check what are we having. We are having z is equal to negative half minus root 3 over 2 multiplied by I. So this would really be easy as well. Let's check number 2. We get z is equals to negative 1 over 2 minus root 3 divided by 2I. We want to write this in a polar form or a modulus argument form. So you need you need two things, I mean to say. That is your modulus or absolute value of z, which is your r. But it makes more sense if you graph these points properly. So I'm going to say, well, let the point P be negative 1 over 2 and negative root 3 over 2 there. So you can graph this situation. You can see that it's going to be in the third quadrant. This is going to be in the third quadrant because the points are all negative, you know. The points are all negative. I just need to really draw my triangle properly. Okay, I guess now it's fine. So I can really enlarge this one here. Cool. Well, the point P, we're talking about this one there. So you will see that the x, the adjusted length, is going to be negative 1 over 2, and the opposite one is going to be negative root 3 over 2. You just need to find this particular length here. How do you find that? You're going to use your Pythagoras theorem. That is to say, your r is going to be the absolute value of z, which is going to be equals to the square of your adjacent and your opposite length. And then you square that. That is a negative root 3 divided by 2. And then you square that. And then as a result, you are going to say to yourself, well, this becomes a quarter. And then a plus, I think this is really going to be 3 over 4 in my imagination. So as a result, you get 4 over 4, which is going to give you 1. So it means this particular one there it's 1 units. So that is your r. It's really 1. You don't have to really show them this unnecessary step. I'm just trying to show you for the benefit of your attention. I just now need to get the principal angle or the argument, which is basically going to be something like that there. All right, now check. If you want to get this particular angle called theta, then check the quadrant in which this situation lie. There are many ways to do it, by the way. I showed you 3 for the first one. I could also show you the fourth one, the things I'm respecting time. But I can show it with the one of modulus. Like when I teach in class, I teach the modulus one. But this one is the general one. You can really summarize the work for yourself here to say, if I'm to use the trig ratio, my advice would be that you use, you can use sine and the cos and the tangent. But check the quadrant. I'm now in the third quadrant where it's only tan that is positive. So I can use tan here to say, you can use sine. Please use sine and the cos to verify. I'm going to use tan because in this quadrant, tan is really positive, you know. So I'm going to say to myself, well, a tangent of theta is going to be the opposite over the adjacent. And that is what... let me check. This is really going to be opposite. It's negative root 3 over 2. I divide it by negative 1 over 2, you know. And then now this is going to give me, if you simplify this situation, it's going to give you positive root 3. So therefore, tan of that is going to give you this one. So you just need to get your reference angle. So your reference angle is primarily going to be the arctangent of root 3, you know. So that is primarily going to give you a beautiful stuff of pi over 3 if you type it in your calculator. So this will be easy now to say that you are in the third quadrant. Remember, I said in the third quadrant, you have a pi plus some reference angle. All right. So it means now your theta is going to be equals to pi. It's going to be pi minus the reference angle, which is primarily pi over 3. You know, I mean, it's plus 3. This should be plus 3. We are in the third quadrant. I was still on the second quadrant. We are in the third quadrant where it's plus. So you will see that if you do it nicely, you're going to get a 3 there. And this is going to be 3 pi plus pi. And as a result, math tells us that this becomes 4 pi over 3. And if you are working with the modulus methods, you're going to get a negative 4 pi over 3. Because you'll be working it in reverse, you might get a negative 4 pi over 3 if you work with the modulus one. So, but they are all correct. They are all correct. So therefore, Z is going to be equals to R, where R is what? You got 1 into cos of the angle. The angle is 4 pi over 3, and then plus I sine of the same angle, and that is 4 pi over 3. And then this is how you're going to represent that in a polar form. And thank you very much for watching. If you want clarity, let me know, comment, like, and share it to your friends. And if there's any chapter that you want me to do in algebra, please let me know. I will do it for you. And thank you very much for watching. See you next time.